Okay, pre-calculus students, we're on page 2 of your graphing polynomial notes. So these problems are similar to the ones we just did. This time we have a triple root at -4. Let me add a few more lines to this. And this. And while I'm at it, I'll just do this one. Okay. So -4, -1, and 3. All right, the lead coefficient is the a, so the lead coefficient is greater than 0. It's positive, which means your right side is going up. So you have a triple root at -3, so I didn't really draw this with enough wiggle. Remember we said that a triple root goes through with a wiggle. So it could look something like this. Instead of passing straight through, it changes so that it was concave up here and then it's concave down. That's going to produce your wiggle. All right, at -1, it's a single root. So we're going to pass straight through at -1. And then a double root at 3. So let's see, straight through, and then a double root is going to be a bounce. So something like this. Okay, for D, -4, -1, 3, and a is less than 0. That's your lead coefficient. So your lead coefficient is negative. So that means on the right side we're going down, and let's see, it's a triple root. So right side down, and then, this is a double root. The double root is bouncing. And we also have a double root at -1, which bounces. And then when we get to the -4, we need to go through with a wiggle. So let's see. Something like that. Okay. All right, so now let's graph a whole equation. Here's my polynomial. It's all factored out for you so that you can find the zeros. This is x to the 1. This is squared, which will produce an x squared, and this is x to the 1. So remember, when you multiply x to the 1 times x squared times x to the 1, that gives you x to the 4th, which means your degree is 4. And 4th degree polynomials have the name quartic. So the maximum number of zeros is equal to the degree. The lead coefficient would be the number in front of your term with the biggest degree. This is 1x, this is 1x, this is 1x, and out here you have a -1. So 1 times 1 times 1 times -1 gives you a lead coefficient of -1. You can find the zeros from the factors. So you set the factors equal to 0. Okay, so the zeros, this one is going to give you 3. If you have x plus 1 equals 0, that gives you x equals -1, and x minus 2 equals 0 gives you x equals 2. So your zeros are -1, 2, and 3. All right, the constant term is the term that doesn't have an x, and that's going to be also the place where you cross the y-axis. So you can substitute a 0 in for your x's to find your constant term. So let's see what would happen with that. I have a negative out front. You can think of that as a -1. 0 minus 3 is -3. 0 plus 1 is 1. And 0 minus 2 is -2. So that gives me 6 times -1, -6. So my constant term will be -6. X-intercepts, those are the same as the zeros as long as these are real numbers. So those are exactly the same. -1, 2, and 3. End behavior, using arrow notation, so that's like the short way. Because our lead coefficient is negative, that tells you the right side goes down, and your degree is even, which means that the ends match, so the left side goes down. And down here, you're doing the same thing but with limit notation. Notice here it's telling you the left side first, so as x goes to -infinity, that's this one. F of x goes to -infinity. And as x goes to +infinity, f of x goes to +infinity. The maximum number of times the graph will turn is 1 less than the degree. So 4 minus 1, which equals 3. Are there any zeros of multiplicity greater than 1? So if you have a factor that's squared, that's this one up here, that gives you a double root. So we have a double 0, or a double root, at x equals -1. Okay, y-intercept, that is the same as the constant term. You get that by putting 0 for all your x's. So y-intercept is -6, and you can write it as a point, 0, -6. We'll do domain and range after we do the graph, and we'll do this interval then as well. So let's take a look and see. We need to mark our zeros, -1, 2, and 3. Our end behavior is down and down, and we're going to have a bounce at -1. So this side's down and this side's down. And we're going to have a bounce here, and we need to go through, where is our constant term? We need to go through -6. 1, 2, 3, 4, 5, 6. So we have a y-intercept of -6 we have to go through. So when we bounce, we're going to come all the way down here and go through this point, and then put your arrow here. So this is your y-intercept at -6. So it looks like your domain is -infinity to infinity. Really, it should be that for any polynomial. And your range starts down here at -infinity, because these arrows keep going down, and they go up to some maximum value here, and we don't know what that is without a calculator. So we're going to say -infinity to some maximum value. We have one, we just don't know what it is, and you would include that value. Okay, so if you did any other work, oh, we need to do our interval, but if you had done any other work, you could put that down here. So interval where f of x is greater than 0. Well, it equals 0 here. This is still less than, so it's just this one interval here between 2 and 3. So it starts being greater than 0 just after the 2, and then it's greater than 0 until right before the 3. You don't want to include those because f of x equals 0 at those points. All right, so I'm going to stop this video and make you one more for the third page.